Hello and welcome to this low-level JavaScript series on building parser combinators from scratch. My name is Francis Stokes, and this is actually the second episode in the series. If you haven't seen the first one, you can check out a link to the playlist in the description. So in the last episode, we explored how parser combinators are used by playing around with the arcsecond library. In this episode, we'll actually begin implementing our own parser combinator system. We looked at a number of different parsers, including the string str parser, which matches exactly the string that we specified. And we also looked at the sequenceOf parser, which takes an array of parsers and executes them in sequence, collecting up their results. If any of the parsers in the sequence don't match, we get an error. These are the two parsers that we'll focus on building today. They'll give us a good idea about how the mechanics of parser combinators actually work under the hood. We're going to start with the string parser because of its simplicity. So what we're going to do is we're going to model it as a function. Clearly, we're going to need to take in the string we need to match, but we're going to need more than that. How we're going to use this in the end is we're going to make a parser, and we're going to call str with whatever we want to match. And this parser, it's not actually going to do anything until we run it. And the way that in the end we're going to do that is we're going to have a method called run. And there we'll pass a string. And so when we actually run it, this information needs to be transmitted to the parser somehow. So we need to take a target string. I'm going to make it that this is a curried function. So this first part is a function that we call with hello, and that gives us this s variable. But then now this whole thing is a function that's waiting for target string. Now it's as easy as just checking if the beginning of the target string matches the string that we provided before. If it does, then it's successful, and we need to provide the result somehow. If it's not successful, then we should provide some sort of error. There are many different ways we can choose to implement this, but let's do the simplest thing right now. We'll return the string if it's successful, and we'll throw an error otherwise. So, tried to match the string, but got target string, and we'll just take the first 10 characters of it. So let's test this out. Since we don't have a .run method at the moment, because these are just functions, let's actually write a function just called run. The run function. So that's going to take a parser and it's going to take a target string. And what we're going to do with that is we're going to say parser, and we're going to give it our target string, and then we're just going to return that. So let's see how this works. We have our parser here, but now we can sort of take run, put run over here, and we'll just try this to see what it's like. And what I'll do is I'll wrap this whole thing in a console.log. Okay, what I'm going to do is I'm going to put the real string in there that we want to match. So now we can run node index. How it works. Hello, we see the hello there. And if it's not correct, then we'll see an error. Tried to match hello there, but got hello not. So let's imagine for a second that this parser was part of a larger sequenceOf, like we had in the previous episode. If we had more than one string we needed to match in a sequence, how would the different parsers understand where they should start parsing the string from? You might think perhaps that that's the job of sequenceOf, to provide exactly the target string to each parser. And that would definitely be one way of doing it. But that's going to complicate sequenceOf quite a lot. And it's also going to start to add a lot of complications later on when we add more and more parsers to the library, because we're going to have to build that same kind of management logic into every parser. Instead, I'm going to do something different. What we're going to do is we're going to provide here as a parameter an index. and that index is going to tell us where we should start looking at the string from. Okay, so what we can do is we can take target string, we can slice it from that index. That's going to give us everything from this index until the end of the string, and then we can check if that starts with string s. And then if we're correct, we're going to return s. Otherwise, we can provide the error message this. But here now we should add index. Now, this is one part, but how is sequenceOf then going to know that it needs to start the next string at a certain point? Well, it could look at the result that we've passed back and see how many characters are there and update the index. But instead, we could say that we return an object that has a result, and the result will be s. And the new index is index plus s.length. And so here we've actually updated the next parser with the same information that we got in, except we don't have an object here. We have two parameters. We can say that we're going to receive a parser state here. I'm going to destruct the target string. I'm going to destruct the index. And now we're taking in a parser state, and we're returning something that's almost a parser state. If we just spread out the old parser state above and only override the result and the index, now we've got something that takes a parser state as input and outputs a parser state. Let's see if this still works. We're going to have to make a small modification to run, of course. We're going to have to sort of construct an initial state. Our initial state will have a target string, which is just the same as this one. We're going to start at index 0, and we won't have a result yet. It will just be null. And now we can run our parser with our initial state instead. And what we'll do is now we'll just return the final state. So let's see if that also works. And we'll get rid of the incorrect message. Okay, so now we can see we got an object as output with the same target string that we expected, with an updated index of 12, and a result of hello there. Now, this format, that a parser is something that sort of receives a parser state in and returns a parser state out, this is going to be the format of every single parser that we build during the series. These parsers are just going to be a kind of specialized function that sort of takes in one parser state and transforms it and outputs a new state. Now let's take a look at sequenceOf. We already know it takes an array of parsers, and we know that it needs to return a function that takes in a parsing state that's going to transform that into a new parsing state. I'll collapse string here just to get rid of it. We know that we also need to end up with an array that contains all the results in the end. So let's just go ahead and make that first. Const results is an empty array. Then we're going to have to loop through each parser in the array and get the next state from it. So what I'm going to do is I'm going to create a mutable variable called next state. And I'm going to, for now, just set it equal to our first parser state. Now we can loop through each parser. So we can use a for-of loop to do this. So we can say for let p of parsers. And here we can say next state is going to equal running the parser on the old next state, the previous state. And so what this is going to do is it's going to advance this parser first on what we first got, and then through every subsequent parser. And then all we have to do in the end here is to take the result that this parser got and push it into our results. So let's see next state dot result. And result, if you remember, is the key where we put what we parsed. Finally, what we can do is return the last state that we got. So we'll just spread that out into a new object. But what we'll do is we'll overwrite the result object with our array of results. let's see how this works. So what I'm going to do is I'm going to modify our parser. And I'm going to create an array of parsers. The first one will be the string hello there, and the second one will be the string goodbye there. So hello there, and then immediately goodbye there. Let's try that out. So now we see we advanced to index 26. And we have a result that is an array of 2 parsers. So we've actually very simply implemented sequenceOf there. There are a couple of more things that I want to address in this implementation though. The first is how we're currently handling errors. Throwing errors is fine, but there are plenty of times when we want to be able to recover from those errors while we're inside a parser. In the last episode, for instance, we looked at the choice parser, which would be able to use whichever parser was actually the first to succeed. That would mean we would need to sort of catch errors in line in the choice parser, recover from them, and it would get messy because that would mean we would need to catch those errors and we would need to make sure they're the kind of errors that we're expecting, and then we would have to try and recover. It's definitely a way that you can do it, but personally I find it a bit inelegant. So instead we're going to implement a slightly more functional solution, which is to encode errors inside the parser state. So let's go back to the string parser. Okay, so down here, if we're unable to get into this successful match branch, what we end up doing is throwing the error. What I want to do here is instead, I want to return an object, a parser state object, just like the one we got. And actually, I'm going to overwrite the previous one because I want to keep in any information that's already there. But what I want to do now is I want to set a key called error. And the error is just going to be the message that we have here. And I'm going to add a second key, which might seem a little bit unnecessary, but it will become clear later why, which is called isError. And I'm going to set that to true. Let's just try that out and see what happens. So let's go back to a simple parser. Try to match hello there, but we actually just get hello. Okay, so what we see now is that we still have a parser state. We're still at index 0 because we weren't able to advance. The result is null, but here we have an error, and the isError is true. Now, what we want to do is we want to put all of these keys into our initial state so they're always there. So let's go ahead and add isError. We'll make that false to begin with, and we'll set error to null, just like the result. So now, if we parse successfully, we'll see isError is false. Otherwise, we'll see the same kind of result. And in both cases now, we receive the same kind of object. I personally like this because we've separated 2 kinds of errors. The ones that we expect and we associate with this kind of problem, so parsing errors, and we've separated those from unexpected errors that might happen in our program, mistakes in code. We shouldn't try to recover from crashes and other kinds of errors unless we expect them. Now, of course, if we were inside this string parser and we already had an error inside the parser state, then we probably wouldn't want to actually keep parsing the string because that's going to do all sorts of weird stuff. So what we can do is we can pull the isError key out here and we can just do a quick check. If isError, then just return the parser state. And that's going to have the effect of just propagating any error that happens anywhere in our parser system all the way down to this final run, and it will be returned to the user. And that allows us to write this parser in a way where we don't need to try and catch and make sure that it's not an unexpected error. sequenceOf is going to have to do that as well. So here we can just check if parser state .isError, then just return parser state. Finally, I'm going to add some utility functions here because it starts to become a little bit of a problem, create and spread out all of these objects. It becomes a bit messy and hard to read. So I'm going to go to the top here, we'll just fold these up. And I'm going to add some functions that are only used to update state. So let's say update parser state. And what we'll do is we'll take the old state and we will take the new index and the new result. And here what we'll do is we'll just do all of that spreading and updating here. So we'll spread the old state, we'll update the index, and we'll update the result. And notice that this gives us a fresh object every time. We want to do this in an immutable way. You might already see why this should be an immutable system, but I'll go into more detail on why it's immutable in the next episode. Okay, so we've got the case update the parser state. We also need to have the case of creating an error. So let's just say update error or parser error. We'll take the state and the error message. And here we will spread out the previous state. We'll definitely say that isError is true, and we'll set error to our error message. So let's go in and clean these previous ones up. If it's a success, then we can return an update parser, not parser error, update parser state, the previous parser state in there, the new index, which is index plus s.length, and the result, which is just s. And that kind of cleans that whole thing up for us a little bit. And finally, we'll do the same thing with the error. So we'll update the parser error. I'll throw in the previous parser state, and we'll just put our message in here directly. But that already improves the readability of the string parser. So we can also update the sequenceOf. So update parser state. So here we have the next state. Here we don't actually need to update the index. The index should stay the same. Maybe what we can do is we can add just a simple utility method which just says update parser result and doesn't need an index because it keeps the index from the state. And then we can keep that nice and clean as well. So we'll just say update parser result. Okay, great. Okay, so we'll first try with the string hello. We see here we got an error and we add there in. And something's wrong. Yes, okay, so we need to not have a dot here. Okay, so in this case, yeah, we see everything is updated correctly. And let's just try it quickly with sequenceOf just to make sure we didn't break anything there either. So we'll first get the hello string, then we'll get goodbye there. So hello there, goodbye there. Great. Finally, with all that in place, we can take a look at the other thing that I want to address, which is that we have an edge case, which hasn't been considered. What if we were in the string parser and we were trying to parse something, but we didn't have any input left? So the target string, when we slice it, we actually don't have any characters left. So that should be a special kind of error, which is unexpected end of input error. And since we're slicing the string here, let's just put it into a variable. So we'll call this sliced target. And what I want to do is I first want to check, is sliced target, does it have a length of 0? If it does, then what we want to do here is we want to return an update parser error with our previous parser state. Well, let's give an indication of which parser we're in string. And let's say unexpected end of input. Tried to match S, but got unexpected end of input. Now, we can check that by simply trying to parse an empty string here. We should see, tried to match hello world, but got unexpected end of input. Great. So that's probably enough for this episode. To recap, we created a data structure that represents a parser state, and we implemented parsers that were able to transform this state in a specific way. We looked at different kind of method for handling errors, especially the kind of errors that we expect to encounter in our library. And finally, we covered the edge cases that could come up when dealing with things that point to a finite data structure like a string. In the next episode, we're going to dive deep into how we can embed these parsers into a class so that we can write interesting methods like map, as well as building up some more interesting parser combinators. I hope you've enjoyed this installment of the series. If you have any feedback, I'd love to hear about it in the comments or in the low-level JavaScript subreddit. That's r/low-level JavaScript. Please consider subscribing if you want to see more of these episodes. Thanks for watching, and I'll see you next time.